Okay, so now coming back from break, we're going to do a little bit of review, and we're going to do that in the way of kind of looking at stuff we've done before, only making it more difficult. Like this. Looking at something like this, of course, we're solving an equation. In our first step, we always find the equal sign, and we identify which side of the equal sign has the variable. Now, in this case, there's an x, or the variables, on each side of the equal sign, which means we have to do what? We have to get rid of one of them. Which one do we get rid of? The smaller one, which is the 3x. So we subtract 3x, and it is now gone, leaving us with just 48 over here. But our basic rule of any of these equations is whatever we do to one side, we have to do exactly the same thing to the other side. Because remember, this is like a balanced scale, and we have to keep it balanced. So we took 3x's off of one side. We have to take 3x's off of the other side. Well, over here, where can we take 3x's away? The 8x. From the negative 7, we can't take x's away from that because it's not x's. So that negative 7 isn't going to change. But 8x minus 3x gives us 5x. So now we have an equation that we're more familiar with as far as solving. What do we do with that? Well, we add 7 because it's a negative 7 or minus 7, so we're going to add 7. Leaves us with 5x here. We're going to add 7 over here, gives us 55. And then, yep, so that's x times 5, so we're going to divide by 5. X equals 11. Look familiar? Yeah. Sort of? Okay. How does this change if we have something like this? What do we have to do there? Well, of course, whenever we see parentheses, it should scream at us, do this part first, right? So we look at the parentheses. Is there anything to do inside those parentheses?
You have to multiply the 8.
Okay. Yep, you're getting ahead of me, though. First thing you got to always do is you got to look in the parentheses. Is there anything to do in the parentheses? And here the answer is no. 2x and the negative 7 cannot be combined. So the second question then, is there anything that can be done to the parentheses? And that's where you were going. The parentheses can be multiplied by 8. And as you were saying, everything in the parentheses has to be multiplied by 8. So 8 times 2x is 16x. There's no other x's. So there's nothing multiplying the x. That just stays an x. 8 times a negative 7, negative 56. So now, add 56. So you've got the 16x over here equals 80. And then divide by 16. Very good. X equals 5. Let's try another one. Looking at this one, again, we see parentheses. It screams, do something here first. Anything to do inside the parentheses? No. To the parentheses? Yes, times 5. So we start out. 5 times 7x is 35x. Then it's 5 times negative 4, which is negative 20. Now what do we do with this plus 5 over here? Well, this step, nothing. But now we do have to keep combining. On each side of the equal sign, we can combine whatever we can. Well, over here, we can combine the negative 20 and a positive 5, which is negative 15. So 35x minus 15 equals 90. And then Add the 15. 35x equals 105. And then divide by 35. X equals 3. Well, since you guys are finding these so easy at this point, I want you to try one in your notes. And see what you come up with. So what'd you come up with here? 2. Okay, let's check it out. Again, parentheses, nothing to do in the parentheses, but to the parentheses is times 3. So 3 times 5x, 15x. 3 times 1, positive 3. Okay, and then subtract the 3's. 15x equals 30. And then divide by 15. X equals 2. What do you think? Easy?
I think you did it right.
Think I did it okay? All right. That's always nice to know that you guys approve. This time. Well, since you're doing that so well, try this one. I don't see more pencils going, so let's see what we got here. Tell me what to do. Multiply by the 5, okay? So we get 15x, positive 5. And of course nothing happens there, then what? We combine what we can on each side, so 15x and 2x make 17x. We still have the positive 5. And then subtract 5. So 17x equals 51. And then divide by 17. So x equals
3. 3. I have it right on my paper right here. So
sure.
You guys will laugh to answer.
Okay, well, let's look at something maybe a touch more complex. So 7 times the 2x plus 5 minus 4x equals 5 times 6x minus 3 plus 4.
We're doing this one together, right?
As always, we find the equal sign. And again, there's variables on each side, so we're going to have to deal with that. And there's also parentheses. So we start out with the parentheses. No, we can, when we're doing at this stage, since we're not like solving, we're just simplifying and combining, we can look at each side of the equal sign separately. So I'm going to start out by just looking over here on this side of the equal sign. And I see the parentheses. Anything to do in that parentheses? Nope. To the parentheses? Yes, it's times 7. So 7 times 2x is 14x. Then to complete what's in the parentheses, 7 times the positive 5 is positive 35. Now there's still the negative 4x here. So now we're going to stay on this side of the equal sign. We're going to combine 14x and negative 4x make 10x. You got it. And a positive 35. Now we go to the other side. Over here, we see parentheses. Anything to do in the parentheses? Nope. To the parentheses. Yes, times the 5. 5 times 6x is 30x. And 5 times a negative 3. Negative 15. And we still have the positive 4. So now over here, we're going to combine what we can. Is there anything combined with the 30x? No. How about the negative 15? Yeah, negative 15 and positive 4 make negative 11. Good. Now what? Well, there's still the variable still appears on both sides, so we have to get rid of one of them. The smaller is the 10x, so we're going to get rid of 10x by subtracting 10x. It is now gone. leaving us with 35 over here. We have to remove 10x from the other side. The only place we can take it is from the 30x. 30x minus 10x is 20x, and we still have the negative 11. Now what? It's a minus 11, so we're going to add 11 to get rid of it. Or you could subtract a negative 11 is the same as adding 11.
Yeah, that's what I was, yeah. That's what I was gonna do.
35 plus 11 is 46 equals 20x. And then, so 2.3 equals x. Or 2 and 3/10 equals x if you want to leave it as a fraction.
I have a question.
Yes.
And I think it's okay. I actually take it from one side all the time, and it's still the same answer.
What you'd end up with, a negative 20 and a negative 46, which still divides out to be a positive 2.3. It's just you're working with negative numbers is all, and I try to avoid negatives when I can. But if you,
it's just easier to keep going the same way.
and a lot of people are like that. They like having the variable on the left side, and it makes it easier for them that way. So that's fine.
Yeah, I don't like when the variable jumps from one side to the other.
Can you go back a minute, please?
Well, then you should just flip it.
You can, yeah. If you wanted to, once you got to this point right here, you could just rewrite it and say, okay, that's 20x minus 11, and that has to equal 35. Because you know they're equal. It doesn't matter which one's on which side. You know they're equal, so you can flop the sides if you want to.
Yeah.
There you go. To be honest, I don't care if the math fairy flutters down and whispers the answers in your ear as long as he's right every time.
Do you know where one is?
Not really, no. I know where you could hire one
You're right.
He's sitting over there. I did that.
for the right price.
Pays a diamond an hour.
This one looks simple. So let's have you. Well, right at the beginning is where most people usually make their mistake on this one. Because we see the parentheses, and there's nothing to do in the parentheses. And for the most part, people look at this and they think there's nothing to do to the parentheses, but there is. What is in front of this set of parentheses? The minus. And like many other cases, there's these invisible ones. You know, like the x is really x to the power of 1 and all that. This you really need to think of as a negative 1 times the parentheses. So now there is something that needs to be done to that parentheses. Now the 2x here doesn't change, but this is negative 1 times 5x is a negative 5x. Negative 1 times 1 is a negative 1. Now what do we do? Well, we're going to combine 2x and negative 5x to make negative 3x. And then add 1 because it's a negative 1. So negative 3x equals 15. And then divide by negative 3.
Oh, what? Yeah,
So x is negative 5. You are correct. How many of you had negative 5?
How about 2 1/4?
One person? That is. I'm thinking maybe we should try another one similar to that. It might look something like this. So let me give that one a try on your notes. So we start out with the negative again. We treat it as a negative 1. So the 3x does not change. Negative 1 times 10x would be negative 10x. Negative 1 times 4. Negative 4. What do we do from here? So 3x and negative 10x make negative 7x minus 4 equals 43. And then we are going to add 4. So negative 7x equals 47. And finally, divide by a negative 7, which means x is going to equal a negative 6.7142857143 approximately.
And 5/7.
5/7 works. Yeah, negative 6 and 5/7 works. That's just not as fun to say.
You know, I'm going to do that on the test one these days.
What's that?
Just write it all down.
Sure. If you want to write this one out till it ends, though, you're going to need a little bit more paper. This one doesn't end. It goes on forever. Yeah.
It goes on forever.
Yeah, that one goes on forever.
Well, until 3.000001.
So anyway, let's change gears just a little bit. Now that we've reviewed all that stuff, let's look at things like this. How on earth would we approach this problem? Well, we talked about this before. X over 3 can be thought of as 1/3 x. Like that. Now that we have 1/3 x plus 2x, we can combine these. What's 1/3 plus 2? 2 1/3 x equals 21. And then, to solve for x, we would divide by 2 1/3. Giving us x equals 9. 21 divided by 2 1/3 is 9. I'll let you guys verify that with your calculators or doing it out by hand. Here, I'm going to do it this way. 21 over 1 divided by 2 1/3 is 21 over 1 divided by 7/3, which is 21 over 1 times 3 over 7, which is 63 over 7, otherwise known as 9.
Is anything wrong? Well, okay, that happened. Because I just had a 2 on my answer.
It should be 9, so yeah, you did something wrong.
And I got a
Well,
1/9.
don't I do...
You did it upside down. You did 2 1/3 divided by 21. It should be 21 divided by 2 1/3.
Well, I think I'm having issues with entering the fraction. Shouldn't I just...
On your calculator, so you're going to type in
1
21.
ABC?
We're going to do 21
Yeah.
divided by
2.
2 ABC1, ABC3.
Okay, that's what I did.
Then it equals.
9.
There you go. But there's an alternative to that. Rather than working with the fraction, we could get rid of the fraction. Now this one's really simple because there's only one fraction in here. So the least common denominator is just 3. So if I were to multiply this whole equation by 3, the fraction would disappear. Now every piece, because that's their common denominator.
Okay.
Now every piece every term they call it, has to be multiplied by 3. So 3 times x over 3, that's 3 over 1 times x over 3. Well, the 3's just cross cancel and leave us with x. 3 times 2x is 6x. We have our equal sign. 3 times 21 is 63. Now, x plus 6x is 7x equals 63. We divide by 7 to get x equals 9. Now, in this case, it's about the same amount of work either way. I don't mind working with fractions, so doing the 2 1/3 doesn't bother me. Some people, just multiplying the whole thing by 3 can be confusing. Unfortunately, there are some equations where that is our only option for solving the equation, is to multiply by a common denominator. You had a question, Cody, or comment? Okay. Sure.
Got x plus 6x equals 63.
So this is, remember, this is a 1x.
7x.
So 1 and 6 make 7. Yep. For example, where do I go here? Get back here. For example, we can have something like this. Whenever our variable appears in the bottom or in the denominator of a fraction, we have no choice but to use a common denominator to alter our equation. So in this case, we have x, we have 6, and we have 3x are our denominators. We're looking for least common denominator, in other words, least common multiple. And to do that, we did factors. Well, x, there's no way to factor it. It's just x. How about 6? Factors into 2 times 3. Does 3 factor? No, 3x is just 3 times x. That's all we can do with it. So now we look at this. These two each have an x. This one does not, so I need an x there. So now all of them have an x. These two each have a 3, but this one doesn't, so we need to put a 3 up there. So now they all have a 3. Yeah, this one has a 2 and none of the others do, so each of those needs a 2. So now everything has the same factors, correct? Remember doing this for common denominators for our fractions before? Factor them and make sure everything has the same factors. So now we've got x times 3 times 2, which is 6x. 2 times 3 times x is 6x. 6x. So 6x is our least common denominator, or least common multiple of those numbers. So what that means is we are multiplying this whole equation by 6x. So 6x times 3 is 18x. 6x times 2x. Like this, 6x over 1 times 2 over x. 6x times 2 is 12x over x. Well, what's 12x divided by x? Well, the x divides out, it's just 12. So this is plus 12. And then we have the 6x times 5 sixths. So 6x over 1 times 5 over 6, that is 30x over 6. 30x divided by 6, well, 30 divided by 6 is 5. That's 5x. Now we have 6x times 5 over 3x. So 6x over 1 times 5 over 3x. 6x. Well, you could cross-cancel the x's and then the 3 and the 6, but I find it easier just to multiply it out and divide it out when you have the variables in it. So 6x times 5 is 30x. 1 times 3x is 3x. The x's cancel. 30 divided by 3 is 10. So I have a whole new equation right here that has 0 fractions in it, but we'll have the same solution. So what do I do with this one? So 18x and 5x make 23x. We still have the plus 12 equals 10. And then subtract 12. 23x equals a negative 2 and divided by 23. Sure it does. X equals a negative 2 over 23. I think 0.09, something like that. What do you think? Better than sharp stick in the eye?
Not really.
Not really?
Yeah.
Just a lot of little stuff that's
There is.
Just that, yeah, that.
Let's do one more example, see if it helps. So looking at this one, if I want to get rid of all the fractions, I take all my denominators. I have x, I have 5, and I have 2x. And I need to find a common denominator. This one's actually kind of easy to find. Look at the numbers. What's the common denominator of 2 and 5? 10, and then we take the highest power of the variable. Well, x appears just once in the end, so 10x is going to be our common denominator. Does that look familiar, at least, finding the 10x? Anybody totally lost as where the 10x came from?
on the denominator between 6 or x, but
Yeah, we're just looking at the x, the 5, and the 2x. So,
yeah.
so now we're going to multiply this whole thing by 10x. 10x times 4 is 40x. 10x times 6 over x, well, 10x over 1 times 6 over x, that's 60x over x, otherwise known as 60.
Could you just cancel out the x's?
Yes, you could, yes. So it's just 10 times 6. You got 10x over 1 times 2 over 5. Again, you could cross-cancel the 10 and 5 if you wanted to. I'm just going to multiply out. 10x times 2 is 20x over 5, otherwise known as 4x, equals 10x over 1 times 2, or sorry, not 2, times 3 over 2x. Again, you can cross-cancel the 10x and the 2x to get just a 5. But over 10x times 3 is 30x over 2x. The x's cancel. 15 divided, or 30 divided by 2 is 15. So it's just 15.
Why? Oh wait.
So now we solve this equation. 40 and 4 make 44x. Yep. So now we're going to subtract 60. So 44x equals a negative 45. And then
You divide 45, or 44 by 45.
we divide by 44. So negative 45 divided by 44 is a negative 1 and 1/44.
Oh. I don't know what you sounded that you know that on top of your head, but it looks like
It's not so bad. Let's get used to it. Okay, let's look at something just a slightly bit different yet. This one. What's different here? There's x squareds in it, right? Not as tough as it looks. Because this is minus here. We can combine this side. What we're looking at here is x squared minus 3x plus 7. Minus, we're going to line this up. The x squared is going to go with the x squared. The minus 4 goes with the other ones. The negative 4 ones and the positive 7 ones go together. This is minus, right? So 7 minus a negative 4 becomes 7 plus 4, or 11.
Why didn't you change your sign?
We will. That's what we're doing as we do our problems here. You could make this a negative x squared and a positive 4 and then just combine. That works too if that's the way you'd rather do it. That's just kind of a gimmick. So now we've got negative 3x and nothing. Well, this is still going to be negative 3x. X squared minus x squared cancels out. So what we have here is negative 3x plus 11 equals 7. Then what? So subtracting 11, negative 3x equals negative 4. Divided by negative 3. So negative 4 divided by negative 3 is a positive 1 1/3, or 1.33333.
Take it up a little bit, please.
Yes.
See, I would want to make that a negative 3. Or,
Good.
I'm sorry, a positive 3. At the
This?
end there, no, the 7 and the 4.
Oh, so yeah, but it's not adding, it's subtracting. So this is 7 minus a negative 4.
Why isn't it like serious? In my head, it's
That's greater than the 19.
Because it's subtracting here.
some people that know.
These are ones you'll have to practice with a little bit. This is something you'll come back to when you review the polynomials a little bit.
Okay.
The subtracting was in here, so it had to be 7 minus a negative 4. When you subtract a negative, it becomes plus a positive. So 7 minus a negative 4 becomes 7 plus
Oh, that's
the
okay,
positive.
that's-
Remember, always subtraction becomes add the opposite.
Yeah, that's what I'm thinking because I would have just changed the signs.
Oh, sure. And then you'd have been okay.
Yeah. Okay.
Well, the good news is that's all the new material for today. There is a new quiz due tomorrow, Tuesday, at 11:59 p.m. There's a new homework that is due on Wednesday at some point in the afternoon. I believe it's next week. We're going to they're doing some sort of a survey, technical college survey or community college survey. And this class has been chosen to participate in it.
What's that
So at some point there'll be someone coming in to give you guys a survey.
So make
Well, just all they're doing is making sure that WITC is doing their job. It's not about me, it's about the school in general.
Oh, I was gonna say make all check payable to the TME